Hello guys, welcome in today's video. In this video, we are going to talk about what are the major differences between Python list and NumPy array. As we all know, Python programming language provides developers with versatile data structures for managing collection of data. Two commonly used data structures are lists and arrays, while both serve similar purposes. But still, there are many differences between their implementation, performance, and capabilities. First, let us discuss Python list and NumPy arrays. A list is a versatile data structure that can hold elements of a different data types. Lists are mutable, meaning their elements can be changed after they are created. They are created using square brackets and can contain any number of elements separated by commas, while on the other hand, NumPy is a popular numerical computing library for Python that introduces the concept of arrays. NumPy arrays are homogeneous, means they can only contain elements of same data type. They are most efficient for numeric operations and offer extensive support for mathematical functions and operations. Creating a Python list is straightforward. All you need is to initialize an empty list or create a new with predefined elements. Here is the example for both of these conditions. On the other hand, NumPy arrays can be created from existing lists or using built-in functions provided by library. Here is the example. Suppose you have to create an array from an existing list. So all you need is just to write np.array, and within that method all you need is to place your elements in the square brackets. Now the second example is here that creates an array of zeros. Python list can handle elements of different data types with the same list. Here is the example. Suppose we have a list, and as you can see we have integer, string, boolean and floating values. NumPy arrays are homogeneous and can only contain elements of the same data type. Here is the example. As you can see, all the elements here are integers. NumPy arrays are more memory efficient as compared to Python list, especially when dealing with large dataset. It is because NumPy arrays are implemented in C and allow for more efficient storage and manipulation of data. NumPy arrays outperform Python list in terms of performance, especially for mathematical operations and functions. It is due to NumPy's ability to leverage high performance C code for numerical computations. Python lists supports both positive and negative indexing as well as slicing operations. Here is the example. My list contains elements from 1 to 5, and suppose I want to access the first element. So all we need is just to print my list. Within the square bracket I have written 0, which actually returns the element on the 0th index, that is 1. While on the other hand, here I am accessing the element 5 with the help of negative indexing. And the last, here we are using the slicing. Suppose I have to access the element within a certain range. So in this case we are actually accessing the element from the index 1 to 4, and here is the output 2, 3 and 4. Now keep in mind that if there is a 4, then it always return n minus 1. Suppose my value of n is 4, then it will going to return the values from 1 to 3. NumPy arrays also support similar indexing and slicing operations. Here is the example. We have my arrays in which we have the elements from 1 to 5, and the same indexing methods we are going to perform here, positive indexing and negative indexing, and the output will be the same, and same goes for the slicing. Both Python list and NumPy arrays come with a variety of functions and methods for performing operation on the data they contain. Python list provides methods such as append, extend, pop, etc. for modifying the list, while on the other hand, NumPy arrays offers functions for mathematical operation like np.sum, npmean, np.max, etc. along with methods like reshape, transpose and etc. NumPy arrays excel in mathematical operation as they are optimized for numerical computations. Here is the example. Suppose we have the array 1 and array 2, and if we want to add the elements, then the addition is going to perform element wise. So the result would be 1 plus 4 5, 2 plus 5 7, 3 plus 6 9. NumPy array supports broadcasting, which allows for arithmetical operations between arrays of different shapes. Here is the example. Suppose we have an array and we have to multiply scalar with it. So the scalar multiplication can be possible in NumPy array. NumPy arrays can represent multi-dimensional data efficiently, making them ideal for tasks like matrix operation and image processing. NumPy arrays are widely used and compatible with various Python libraries such as pandas and matplotlib, making them an integral part of the Python scientific ecosystem. While Python list offers more flexible due to their heterogeneous nature, NumPy array provides a more structured approach to the data manipulation, especially for numerical computations. Python lists are more flexible in terms of the types of data they can hold and the operation they support, whereas NumPy arrays are specialized for numerical computation. Python lists are implemented as dynamic arrays that store references to objects in memory. Each element in a Python list is essentially a pointer to the actual object, which can be located anywhere in the memory. This scattered memory location can lead to memory fragmentation and increase memory overhead, especially for large lists with heterogeneous data types. While on the other hand, NumPy arrays are stored as contiguous blocks of memory. This contiguous memory layout enables efficient elements access and optimize memory operations such as vectorized computations and cache utilization. Since NumPy arrays store fixed size items of the same data type, they have a more compact memory presentation compared to Python lists. In conclusion, Python lists and NumPy arrays serve similar purposes but different in their implementation, capabilities, and performance. Python lists offer flexibility and ease of use, while NumPy arrays provide efficient